Earlier, we talked about the limitations on the use of the wildcards. We also saw examples showing difficulty to insert data items into a collection parameterized with the extends wildcard, and also difficulty to read items from a collection parameterized with the super wildcard. So with these limitations in mind, when it comes to the use of the wildcards, we should follow this principle, the get and put principle. We use the extends wildcard when we only get values, and we use a super wildcard when we only put values, and we don't use a wildcard at all when we have to do both get and put. Here are some examples showing how to use the wildcard in our code. This sum method that takes a collection as a parameter, but this collection is parameterized with the extends wildcard. It says wildcard extends number, which means this sum method can take a collection of number, can take a collection of integer, can take a collection of double, or can take a collection of any subtypes of number. Another one, the copy method that takes two parameters, destination and source. Destination is a list parameterized with the super keyword, and source is a list parameterized with the extends keyword. So what this method does is we read data items from the source and we copy them or store them into the destination. And this is exactly what this principle tells us to do. A third example, this count method. This guy takes two parameters. The first one is a collection, and the second one is an integer. What it does is it's going to add or insert integers from 0 up to n-1 into the first parameter. Because the first parameter is a collection parameterized with the super wildcard, we can do insertions. So that's not a problem. Because it says wildcard super integer, so that means we can take a list of integers, we can take a list of numbers, or we can take a list of objects. So all of these lines of code should work fine. Earlier we saw this max example, and we decided that type T should implement a comparable of type T, which works for a lot of the types. For example, it works for integers, it works for double, for floats, for string, because integer implements a comparable of integer, and double implements a comparable of double, and string implements a comparable of string. So all of these should work. But we did see an exception. We had a list of local dates. But when we try to use this max on a list of local dates, the compiler did not compile. The reason being, local date implements comparable of supertype of local date, which is chrono local date. So that was why the compiler didn't compile. So to solve the problem, we need to use the super wildcard. So instead of saying T extends comparable of T, we say T extends comparable of super T. So if we do this, as we see on this page, it will work for a list of local dates. So when we have to do both put and get, we understand from the principle that we should not be using either the extend or the super wildcard. So what we do here is we use a collection of number without a wildcard, so it does allow us to add or to read. There are exceptions though for this get and put principle. So when we have a parameterized type with the extends wildcard, normally we cannot add items, but we can add a null value. So this is acceptable. And similarly, for a parameterized type using a super wildcard, normally we do not read items. But in this case, as an exception, and we can read items as objects, and that's not a problem either. And now let's look at what is an unbounded wildcard, and what is wildcard capture, and what is a helper method. So the wildcard, the question mark itself, without the super or extends qualifier, it is called the unbounded wildcard. So actually, this guy is equivalent to, for example, we have a collection with this unbounded wildcard. It is the same thing as a collection with the extends wildcard. Wildcard extends object. So these two are actually the same. So collection with parameterized type unbounded wildcard. This is the super type of all parameterized collections. So one important application for this unbounded wildcard is wildcard capture. So imagine we want to do this. We have a list. We want to copy or we want to move the first element to the end of the list. So what do we have to do? First, you have to read, you have to get the first element from the list, and then you have to add it at the end of the list. Because we're using, this unbounded wildcard is actually a wildcard with using the extend keyword, so we cannot add items. So what can we do? We can use wildcard capture to solve the problem. So inside this copy first to end method, we call a helper method. So the copy first to end method takes a parameter of list, and this list is a parameterized type with the unbounded wildcard. But the helper method takes a type of list T. So this list of T, we can get or we can put. So it works for both. So inside the helper method, we can get the first element, and then we can add it at the end of the list. So here's an exercise. Again, you can take a few minutes and find out a solution with the given code, with the given startup code. And you can find it under Sakai and lectures, I believe. Generic programming with generics. Why do we need generic programming? Generic programming is actually the technique of writing programs to accommodate the broadest possible ranges of types or inputs. So for instance, we have considered several implementations for the max function, and the goal for doing that is we're trying to find the most general or most generic implementation for this max method. So there's some demos for you to look at. You can find it in the demo code uploaded under Sakai lesson 11.